Okay, so in this section we're looking at AA, SSS, and SAS triangle similarity. Okay, so just like we had to prove ways that we're proving triangles congruent, there's some shortcuts, 3 of them, that we can use to prove that 2 triangles are similar. The first one is a postulate. We're going to call it the AA similarity postulate. And the idea here is simply that if I have one triangle and I have another triangle and this angle is congruent to that one, that angle is congruent to this one, then I have sufficient information to know that these 2 triangles are similar. And basically what it comes down to is if I have 2 of the angles, then I have the third one, and if I bounce that through something like the hinge theorem, I end up being able to say that the sides are proportional. So that gives me a pretty easy way to show similarity. Just if I know that 2 angles of one triangle are congruent to 2 angles of the other, then I know, in fact, the triangles are similar. Okay, so the second one is going to be the SAS similarity theorem. And this basically says, again, I have 2 triangles. There's one, there's the other one. I know that these sides are congruent or are proportional. So let's call that A, B, C, D, and I know that A is to B as C is to D, and that the angle between them is congruent, then we're going to suggest that those 2 triangles are in fact congruent. Now, in the new notes, I've put in there's better English, I have put a formal proof for this. I'm going to kind of walk through that, but I'm not going to write out all the steps. We're just going to kind of give you a picture of how that proof works. Okay, so in order to do this, I need 2 triangles. So here's one. Here's the other. And we're going to call this triangle A, B, C, and we're going to call this one D, E, F. Okay, so we're going to be given certain information, right? We're going to know that AB is to DE as AC is to DF. We're also going to know that angle A and angle D are congruent. Okay, so I have this proportion, I have those angles. I want to prove that these 2 triangles are similar. So here's what I do. I find the point where I'm going to find a point X here so that this is congruent to that. And then I'm going to draw a line going across here, right? So that these are parallel. So we'll call that Y. Okay, so if these are in fact parallel, then these 2 angles have to be congruent. Okay, so AXY has to be congruent to ABC. That's because they're corresponding angles, which means that the big triangle here, triangle ABC, has to be similar to triangle AXY. And why is that? Because there's one angle in both triangles, there's the other angle in both triangles, I have AA similarity. Okay, so if that's true, then the following statement has to be true. AB has to be proportional to AX, and likewise AC has to be proportional to AY. Okay, so that proportion has to work. Okay, well, all right, but I constructed this in such a way that AX is the same as DE. So I can take out the AX and put in a DE. Now, if you think about this long and hard, and I look at this statement, which is something that I was given, and I look at this statement, well, if they're both true, then the only thing that's different in these two statements is the DF and the AY, which means that DF has to be the same size as AY, which means I now have that triangle AXY is in fact congruent to triangle DEF. Now, if these things are congruent, then I should be able to take that one out and put in triangle DEF, and that's the desired result that I want to get. That triangle ABC and DEF are in fact similar. So, all I need is to show that the sides are proportional, two sides are proportional, and the included angle is proportional, and I get that the two triangles are similar. Now there's a much more formal proof of that in the notes, and I leave that for you to read. It pretty much follows the logic that I've used here, but it's a much more formal and lengthy statement. Okay, so we have one more way to talk about similarity here. Okay, so this one is what we're going to call the SSS Similarity theorem. And again, you have two triangles. Here's one, here's the other one, right? And now we're going to call this A, B, C, D, E, F. And we're going to say that A is to D, as B is to E, as C is to F. And we're going to say that if that's the case, then these triangles are in fact similar. One is a mini-me of the other. So let's see if we can prove that like we did the last one. Like I said before, I'm not going to do like lengthy formal proof, but I'm going to give you kind of the step-by-steps and let you read the proof on your own. Okay, so again, to do this, I need two triangles. So there's one, there's two, right? And again, we're going to call this one A, B, C. We're going to call this one D, E, F. And this time, all that I'm given is that AB is to DE, as BC is to EF, as AC is to DF. I get all three sides setting up proportional. I want to show that these two triangles are similar. So just like last time, I'm going to measure this length DE. I'm going to find a point X, and I'm going to make those the same length. And then I'm also going to draw in a parallel. Okay, so just like last time, I got that those two angles have to be congruent because they're corresponding angles. Okay, which just like last time, I got the triangle AX, let's call this Y, has to be similar to triangle ABC because those angles are the same. A is in both triangles, so that gives me AA similarity. Okay, so from there, that similarity gives me that AB has to be this relate to AX, as BC relates to XY, right? As AC has to relate to AY, right? Okay, but in the given, which is up here, I've got a very similar statement. And the only two differences this time are that EF is now in the place of xy, and DF is in the place of AY. So this means that EF, this one here, has to be congruent to XY. And DF, that one there, has to be congruent to AY. Well, this means that triangle AXY is congruent to triangle DEF by SSS congruence, right? So I just strike out the AXY, I put in a DEF, and now I have triangle ABC similar, not congruent, similar to triangle DEF, and voila, I have proven the SSS similarity theorem. Again, there is a much more formal proof of this in the notes. I leave that to your leisure, and we will be working this next class.